Hi everyone, welcome to the guided notes for the quadratics and polynomials unit. This is guided notes 1 that goes with our quadratic equations review, and this is the notes section. So here we go. We'll get started with a reminder of how to multiply binomials. One method that we use is FOIL, where we multiply the first, and then the outer, and then the inner, and then the last. We can also use this same idea of double distribution. And then the third idea is using this box method where I separate the terms of the binomial 7x and minus 2 and 5x plus 1 of the second binomial. And I'm just going to multiply everything that's in the first row and the first column and the second row and the second column. So I get 35x squared minus 10x. Plus 7x, and then minus 2. The nice thing here, and what this chart is showing, is that I can take those two like terms, which are negative 10x and 7x. The other two terms just come down, 35x squared minus 3x minus 2. This is a nice visual way to make sure that I don't forget to do all of the distribution that I need to do. All right, when we talk about quadratics in terms of a graph, we're talking about some key features. One of the things is the axis of symmetry, the line that cuts it in half. So the line of symmetry is, in this case, the y-axis. It's the line that you fold the function over. When we talk about other features of the parabola, I'm interested in the x-intercepts, also known as the roots, the zeros, or the solutions to this equation. They are when y is 0, and in this case they are negative 2 and 2, and the point negative 2, 0, and 2, comma 0. Okay, another key piece here is the vertex. We talked a lot about the vertex when we talked about transformations. The vertex in this case is the point 0, comma negative 3. Is it a minimum or a maximum? Well, the answer is that it is a minimum point because the parabola opens up. Now, in this last little bit, we talk about factoring. And when the a term is 1, we'll talk a little bit more about this in a coming video, but when the a term is 1, I'm using the product sum method. So it's going to multiply to the c term and then add, or sum, I'll change that to sum, and then it's going to sum to the b term. The c term is negative 12, the b term is negative 1, so two numbers that multiply to negative 12 and sum to negative 1 are negative 4 and positive 3, so my solution set is negative 3, 4. Okay, now this should be familiar as well when we talk about domain and range. Domain is how far left and right the function goes. In this case, the domain is all x values that are greater than or equal to negative 5 and less than but not including 6. Less than but not including because of that open circle. Now the range, we're talking about the y values, and that's from the bottom of the function to the top of the function. So the range is all y values that are greater than or equal to negative 6, and less than or equal to 2. Okay, for a line, the domain is all real numbers, the range is all real numbers. For a quadratic function or a parabola, the domain is all real numbers, and the range is all y values that are greater than or equal to 3. And again, if this were a maximum, it would be all y values that are less than or equal to 3 if the parabola was flipped upside down. A little review of transformations here. When we talk about a vertical shift, we're taking x squared, replacing it with x squared plus c, and so we're shifting it c units up. Now we're taking x squared and replacing it with x squared minus c, so we're shifting the function c units down. So x squared shifting so many units becomes, all right, so when I take, in this case, x squared in blue and shift it into the red function, I'm taking x squared and I'm shifting it down by 2 units, and so it becomes x squared minus 2. I'm not sure what we're supposed to put in these boxes, so we can leave that blank. I think it's supposed to be x squared, and then in red, x squared minus 2. Okay, now if I take x squared minus 2 and I shift it, so from this blue function, now I want to make the red function going from blue to red, and it doesn't always have to be straight from a parent, it can be from a transformed function that I'm making changes. In this case, x squared minus 2 in blue is shifting up 3 units. It now becomes, in red, x squared plus 1, where the function in red is x squared plus 1, and the function in blue is x squared minus 2. All right, when we talk about transformations now in terms of a horizontal compression, 3x squared in blue is more narrow than x squared in red because when a is, the absolute value of a, of course, is always positive, smaller to larger a, so when a gets small, goes from being 1 here to being 3, the result is that it gets stretched vertically. We're going from x squared to 3x squared, so x squared is going to get a vertical stretch when the number out in front, when a is greater than 1. Now, there's a horizontal stretch when there's a fraction out in front, and that's because we're going to say it gets fatter. It's not really the technical term. We'll say that it's either a vertical compression or a horizontal stretch. I remember this because fraction starts with f and fatter starts with f, and so whenever there's a fraction out in front of a leading coefficient, I know that to go from x squared, we'll do that in red, to go from x squared in red to 1/4 x squared, negative 1/4 x squared in blue, the fraction is going to get fatter. We should also mention that that negative makes the function flip over. Okay, on the next page of this packet, you'll see all of these notes filled in. Scrolling down, solving, graphing, and analyzing quadratic functions will be our next video. I'll see you there.